going to be looking at 5e today out of the methods textbook. So this is working on being able to graph a logarithmic function. So there's a few things that we need to know. The first is how we graph. So with a exponential function, like y equals e to the power of x, there's a few points that we know. One is it's always going to cross at the y-intercept of 1. Likewise, we know when x is 1, we're going to have e. Y will be e. Likewise, I also know when x is -1 here, it's our y value will be 1 over e. So those are the 3 points we need to know. When we're talking about the domain will be for all real numbers, and the range will be for all positive real numbers. So as you can see, as soon as we change over to the logarithmic function, the domain and range are flipped, and the y-intercept is now the x-intercept. So that's also where we get these next 2 points, where when x is our base, our a value, our y will be 1 this time, so that's these two have switched. And likewise, when we're down here, when we've got our y value of -1, our x value will be 1 over a, which is what I talked about before for our third point. So those are the 3 points we need to make sure we know. So the first thing I'm going to look at is our vertical translation. So the first thing here is I've got my 3 basic points, my x-intercept. I've got my first point here of when x is 2, y is 1. And I've got here when y is -1, I've got the half for x. My asymptote is x equals 0. So if I've got +2 on the outside, it just means these points are being pushed up by 2, which is what you can see here. So my y values are just changing by 2. Likewise, if I've got horizontal transformation, I am just shifting over by 2 points. So that includes this time my asymptote. My asymptote must move over from 0 to x equals 2. Likewise, this has gone from 1 to 3. So we're going to sketch this graph. So I'm going to focus on Dr. T. Forgive me, I forgot to animate one of those points. So the first thing we always look at when graphing is what does the basic graph look like? So I've got my basic graph over here. I've got my 3 points labeled. I've got when x is 2, y is 1. When y is -1, x is a half. And I've got my x-intercept at 1. So the first thing I need to do is look at my transformation. So I'm going to look at my dilation of factor of 3 from the x-axis. That means I am pushing away. I'm pushing away from that x-axis. So this one here is just going to stay at 1, 0. But these two are going to be pushing away by a factor of 3. So that means instead of saying 2, 1, that 1 is going to be times by 3, and we'll get 2, 2, 3. So I've pushed this down and I've pushed this up. So we can see it's pushing away. Next part we need to look at is this 2 in front of the x. And we talked about dilation when it's from the y-axis. If it's 2x, it's going to be a dilation of a half. So that means it is compressing and getting closer to the y-axis. So that means we're moving this. So this is 2. Half of 2 is 1, so it'll be here. And half of 1 is a half, so it will be moved there. So that's the first thing that we needed to have done. Just ignore that part. That should have been down here, -3. Let's look at this next one. I've got 2 log base e x minus 4. So the first thing I need to do is I draw down my first graph. I've got y is equal to log base ex. I've got my 3 points. We always do dilation first, Dr. T. So again, that dilation is factor of 2 from the x-axis. That means I am pushing away and timesing whatever that y value was, I'm timesing it by 2. Now I've done that, I then look at the next part, and that is I've got a shift in a positive direction of 4. Because how do I make that the 0? X must be 4. So that means these points are moving across 4. So I'm just adding 4 to it. Again, sorry, that is here. I should have changed to 5. 1 plus 4 is 5. So that'll be 5 0. Let's look at this next one. Y minus 2 is equal to log base e, 6 minus 2x. So here, first thing we're going to be doing is looking at our basic graph. Then we're going to see, is there any dilation? And we do have dilation here. We've got the 2 in front of the x, which is a dilation factor of a half from the y-axis. That means all these points are going to be getting closer to the y-axis. So we have e here, so half of e is e over 2. Half of 1 is a half, and half of 1 over e is 1 over 2e. The next part is the r, reflection. So we are reflecting, so whatever those points are there, we're going to move them to the opposite side. Apologies, I should have put a negative here. The next part that after I've done that is my transformation, looking at vertical and horizontal shifts. So I'll start off with the vertical shift of +2. So those points are moving up by 2 spots. Then the second part is I've got the horizontal shift. Now, if I factor 2 out, it looks like I've got 3 there. So that means it's a 3 units in the positive direction. Now, if you don't see that, I'm just going to write on the screen. I'll write up here. So in with those brackets right there, what I could have done is I could have said, okay, I've got 2 factored out. What's left? 3 take away x. That means x has to be it's positive for this to be 0. So that tells me why it's a positive 3-unit shift. Okay, so that means I've pushed them over by 3 spots. Okay, let's look at the change of base formula. I wrote formula twice, apologies. Okay, so the first thing we're going to think about letting y is equal to log base a x. We are then going to take log b on both sides, so we're doing an equivalent action. So that is straight away going to give me log b a y is equal to log b x. So it is an equivalent relationship. The next part is we are going to use our power rule. That means this y is going to be coming out the front. And secondly, we're going to divide everything by log BA. And that gives me y is equal to log bx over log BA. If I substitute y back in, my y value here is log AX. So that gives me straight away log AX is equal to log BX over log BA. Now I can also rewrite that as ln x over ln a. Let's look at the inverse. So the inverse, we're just going to write it as, we're going to say k is equal to log BA. We're going to use our understanding of exponents by saying base b to the power of k is equal to a. So now I've got this, we're going to look at what is k actually worth. K is worth log BA, so let's just substitute that in. So now, from this, we are going to raise both sides to the power of x. So again, we've done an equivalent action. We're going to use the exponent rule. So that means we've got m to the power of n is equal to mn, which means for me, we can just say that we're timesing them. So the next part is I am going to rewrite this, and we know this here is equal to a to the power of x. So I can say a to the power of x is equal to b log base b a x. Okay, this is probably the hardest part that I'll be going through today. So the transformation that takes y equals to the power of x to the graph of y equals e to the power of x. So it's using that identity that we saw before. A is equal to b to the power of log ba. We're going to think about what is our a value and what is our b value. So our a value is going to be e, and our b value is going to be 2. So I'm going to rewrite this. E is equal to 2 to the power of log base 2e. We're going to raise both sides to the power of x, and we're going to apply the exponent rule. Now I've done that, I'm going to interpret this. So if I'm interpreting, we need to be thinking about we started off with y is equal to 2 to the power of x, and we are getting it to y is equal to 2 to the power of log base 2e to the power of x. So that means what is happening? What's happening to that x? We've got a k value, which is talking about dilation. So k is equal to log base 2e. Because it's next to the x, it's going to be a compression, and which means it's a compression of 1 over log base 2e.